Four types of databases explained. The following presentation is set out to explain, discuss, illustrate, differentiate, and contrast the following four types of databases: the relational database, the object-oriented database, the NoSQL database, and the data warehouse. Relational databases.
The definition of a relational database is a collection of data items organized as a set of formally described tables from which data can be accessed or reassembled in many different ways without having to reorganize the database tables. The relational data model allows the designer to focus on logical representation of the data and its relationships, rather than on the physical storage details. Simply put, the relational model enables you to view data logically rather than physically. This is an example of a relational database and how multiple tables are related or connected to one another. There are advantages to using a relational database, namely, it's easy to use, flexible, ensures precision, implements security controls and authorization, allows for data independence, and a data manipulation language. Unfortunately, there are also a couple disadvantages. Any performance issues are difficult to predict. It consumes a lot of physical storage, and the extraction of meaningful data is slow and timely. Originally, databases were flat, and the information was stored in one long text file. This made it very difficult to search for specific information. For example, last name, first name, age, student number, etc. A relational database allows you to easily search for specific information, sort according to any field, and generate reports. The relational database was invented in 1970 by Edgar Frank Codd, an IBM researcher.
Object-oriented databases.
What is an object-oriented database? It is a database management system that supports the modeling and creation of data as objects, much the same as object-oriented programming. It makes use of inheritance, polymorphism, and encapsulation. Object-oriented databases are hybrids of relational databases, which means they also make use of tables as well as objects, and are designed to handle complex data types. Instead of having to break up related data into tables and having to reassemble them at a later stage, object-oriented databases are able to store complex data types in objects, meaning that data breakdown is not required. Results of queries also differ for object-oriented databases. A traditional SQL query for a relational database would result in tuples from a table, while an object-oriented SQL query would result in objects from an object collection. There are several advantages associated with object-oriented database systems, including reduced maintenance, as systems have a longer life, real-world modeling, based on objects rather than data, which tends to model the real world in a complete fashion, improved reliability and flexibility, as objects are able to inherit behaviors and attributes from their parents, and high code reusability. When a new object is created, it automatically inherits the behavior and attributes of the class from which it was made, therefore less coding is required. There are also several disadvantages when it comes to object-oriented database systems, being that object-oriented development is not yet completely accepted by major vendors, and object-oriented development is not a cure-all, meaning that object-oriented database systems are best suited for certain environments. wide-scale object-oriented database systems are still very unproven.
NoSQL database system.
NoSQL is a database management system that was developed to respond to various needs of more modern systems. Systems that need to be accessed frequently, that need to run at optimal performance and process data effectively, that can handle a rise in the volume of stored data and to store and retrieve data not in a tabular format. The different types of NoSQL databases are document databases, graph stores, key value stores, and wide column stores, each with a specific interacting interface as seen below. The benefits of a NoSQL database system include large volumes of structured, semi-structured, and unstructured data, efficient scale-out architecture instead of expensive, large, and slow-to-change architecture, object-oriented programming that is easy to use and flexible, agile sprints, quick iteration, and frequent code pushes. NoSQL has a dynamic schema feature, where schemas are not predefined before data is added. This system allows for insertion of data without these predefined schemas. Development is faster and code integration is more reliable. Dissimilar data can be stored together because of these schemas, as well as extra attributes can be added as needed. The following slide contains a comparison of the NoSQL and SQL database systems, each with respect to types, examples, schemas, and data manipulation.
The data warehouse.
Data warehousing can be shortened into acronyms DW or DWH. In some cases, people even refer to it as an enterprise data warehouse, and then we would use the acronym EDW to shorten it. A data warehouse captures and stores all the information that has ever been put into it from long, long ago, since the beginning of time when the company or the organization began to capture information. We call this historical data. Then a data warehouse can be used for reporting, queries, and data analysis. You see, when you query this database that has so much information from the beginning of time when you started capturing information into it, you can get accurate predictions, accurate information, and you can make accurate decisions, or more accurate decisions rather, on the information that you're given. This is why a data warehouse is suited for strategic planning purposes. The people at the top of the table, and they're the ones to make the long-term decisions using the data warehouse to help the organization. You see, the data warehouse is not volatile, which means when you switch it off, the information doesn't go away. This is very important because it needs to hold all of the historical data from long, long, long ago since you began capturing information into it. We have three different types of data warehouses, which is a data mart. It's a more simple form of a data warehouse, focused only on one subject. Then we have OLAP, which is online analytical processing. And then we also have OLTP, which is online transaction processing. Here we have a data warehouse illustration. On the left side, along with CRM, ERP, and SCM, you could also have other components of ERP. You could also have billing and flat files. All of these form the data sources that make their way into the data warehouse. The link between them and the data warehouse is ETL. ETL stands for extraction, transportation, transformation, and loading solutions. And from there, it goes to the users. The users can analyze it, mine it, or report from it. Data warehouses have many advantages, but I've just chosen 5 to share with you. The first of these 5 is quality and consistency. All of the data that has ever been inputted into the data warehouse was inputted in a similar or even the exact same way. This gives us a level of quality and a level of consistency throughout the entire warehouse. The second advantage is integration from multiple sources. As you would have seen previously, is that there are many ways that the data can make its way into the data warehouse. Even though there's so many ways, it can still be entered into the same warehouse, which is very convenient for the user. The third advantage is reduced cost to access historical data. It would cost a lot of money for SAA per se to keep all of their data in one warehouse in files and folders on paper. But it's so much cheaper for them to just have a data warehouse filled with all of that information, and that makes it easier for them to do queries, easier for them to make predictions, and easier for them to store all of their data. The fourth advantage is it's easily accessible. Like I said with the SAA example, imagine you had to go and find July 1995 and how many flights went out, if SAA even existed in 1995. It would cost a lot of money to keep all of that information, and it would cost you a lot of time as well to go and find that information and to use it to make predictions. Imagine your company has been running for 20 years and you want to find out how many sales are predicted for the next month. You'd have to go and find all 20 years of information on that exact same month in order to make your predictions, which is so much easier just to use a data warehouse. The fifth and the last advantage that I'd like to share with you is that it supports ad hoc reporting and inquirying. Ad hoc means when needed and when wanted. This is very important. It's not like this warehouse will create all of these queries for you that you don't need, all of these queries for you that you would not use, but you choose what you use and when you use it. This is very helpful. For every advantage of data warehouse that I have given you, I will give you a disadvantage. And so the first of 5 disadvantages is moving data from multiple sources. Think of every source as its own person, right? I know I said it's possible to move them from multiple sources. It's just complicated. Every person has their own way of inputting, their own way of processing, their own way of outputting, and more importantly in this IT case, their own way of storing data and information. And then you take all of these different people and all of these different ways of storage and you put it into one person, if I could use that word, called the data warehouse. It's possible, but it's very challenging at times. The second disadvantage is implementation time. In order to implement a data warehouse, it could take a lot of time. Understand that your company business or whatever you're using the data warehouse for has been in operation for a really, really long time, maybe, or a really short time, maybe, but you're taking this data warehouse and you need to add all of that information, if you can, into this data warehouse. That could take time. The third disadvantage is cost, but the cost of implementation. Understand that you must obtain the data warehouse information or the system from somewhere. You must get someone to configure it. You must get someone to put the information inside. I mean, if you have a lot of time, it might be cheaper, but if you don't, it might cost you a lot of money in order to get all of this done. The fourth disadvantage is it's difficult to accommodate changes. Obviously, this also depends on the type of data warehouse that you're using, but in some cases, in fact, in most cases, it's very hard to go back into your historical data in order to make changes. The fifth and the final disadvantage is the extra reporting work that you have to do on a regular basis. Because after you've used all of your other sources, or how else you make statements, how else you give your customers information, how else you collect information, you then need to come into the data warehouse and add that information inside here. Unless you have one of those other systems that incorporate all of that together, and that could be easier. But if you don't, it's extra work, and extra work is not really nice. And so just to close it and wrap it up about data warehouses, I'm going to give you the 7 principles of data warehousing. The first 5 are business principles and the last 2 are IT principles. The first is organizational consensus, and that's just making sure you agree. The second is data integrity, making sure that there's no replication or inconsistencies. The third is implementation efficiency, just having a straightforward design. The fourth is user friendliness, making sure that everyone can use it, right? The fifth is operational efficiency, making sure that it's easy to maintain and easy to support. The sixth is scalability, which is just built in scalability for the growth of the changing business requirements. What that really means in English is just that as your business grows, that the data warehouse will be able to grow, or as it changes, that the data warehouse will be able to flow with you and dance with your organization, basically. And the last of the seven is compliance with IT standards. There are IT standards and they must be complied with. And that is Kumi signing out.
And that concludes this presentation. I hope it wasn't too boring, but thank you for watching.